Welcome to aminacademy.com. In mathematical economics, let us discuss about calculus of multivariable functions. The calculus of multivariable function is a mathematical tool used in economics to analyze system and phenomena that involve multiple inputs like x, y, z. It is used in both microeconomics and macroeconomics. Here are some topics you might learn about the calculus of multivariable functions. Function of several variables. A function that have multiple variables as input are common in economics. For example, a consumer's utility is a function of all the goods they consume. Partial derivatives. A partial derivative is the derivative of a function with respect to one variable while keeping the other variable constant. Optimization. Partial derivatives can be used to optimize functions subject to constraints. For example, to find the maximum or minimum of a function, you can set all of the partial derivatives to 0 at the same time. Analyzing producer behavior. Multivariable calculus can be used to analyze producers' behavior. For example, it can help a firm determine how many units of capital they can give up for one more unit of labor to produce the same amount of output. Now, let us discuss further about function of several variables and partial derivatives. Now, consider the function z z equal f of x comma y. Means z is a function of two variables x and y. Now we have to find partial derivatives. Now first we have to consider dou z by dou x, which means partial derivative of the function z with respect to x, which is equal to the formula limit delta x tends 0 f of x plus delta x. That means x gets small increment and y is not, minus f of x minus y over delta x. Similarly, the partial derivative of a function z with respect to y, that is dou z by dou y, can be written as limit delta y tends 0 f of x comma y get increment. This divided by delta y. This is a basic definition for the partial derivative with respect to x and y. Now we can understand this concept with respect to some example problem. Look at here. That function z equal 4y cube x square. Here we have to find dou z by dou x, which means other than x, all variables considered as a constant. Here with respect to x means this is a constant. So what is constant in the x squared derivative, which is equal the constant 4y squared into 2x, which is equal 8xy cube. Then same dou z by dou y, which means other than y, other things are constant kept. That is 4x squared is the constant here. Then derivative of 4y cube is 3 into 4y squared, which gives finally 4 into 3 is 12, 12 into 4 is 48. 48 x square y square. Next example, to find the partial derivative of z. Z equal 5x cube minus 8x square y square plus 3y cube. Then first you have to find dou z by dou x. Here these functions are three terms here. Then 5x cube with respect to x, so we have to derivative this, that is 5 into 3 is 15x square. But here y square, kept y square is a constant, that is minus 8y square into 2x because x square derivative. Here 0 because it is no x term. Then finally we have 15x square minus 16xy square. Similarly, we can find dou z by dou y. Here, that means this function have x and y. We have to consider x is constant. X variables are constant. So here first one 0 because no y term, minus your minus 8x square, y square differentiation is 2y, plus 3 into 3 is 9y square. So we have minus 16x square y plus 9y square. Now next we'll discuss about rules of partial derivatives, differentiation. Now we consider some rules for the partial derivatives. First is product rule. For the product rule, consider z equal g of x comma y and h of two functions g and h with respect to xy. Then first dou z by dou x. Dou z by dou x equal first function into derivative of the second function dou h by dou x plus h of x comma y and dou z by dou g. Dou h by dou g by dou x. Then second dou z by dou y is equal g of xy into dou h by dou y plus h of x comma y, then dou g with respect to dou y. Now next Next is quotient rule. Look at here. Z, the function Z is g of x comma y over h of x comma y. This first dou z by dou x equal h of x comma y dou g by dou x minus g of x comma y dou h by dou x over the denominator function is square, that is h of x comma y the square. Similarly, dou z by dou y is everything same, but with respect to dou y, that is h of x comma y dou g by dou y, because with respect to y. Similarly, minus g of x comma y dou h by dou y over h of x comma y the square. Now next one, power rule, generalized power rule. Now consider z is the function of g of x comma y power n. N is any real number. Then dou z by dou x is n into g of x comma y n minus 1 into dou g by dou x. And similarly, dou z by dou y equal n into g of x comma y n minus 1 dou g by dou y with respect to y here. These are the some partial derivative rules. So far we discussed about some that means mathematical economics, calculus of multivariable calculus. In that we discussed about function of several variables, partial derivatives, optimization, analyzing producer behavior, as well the function of several variables and partial derivatives, the rule. And we have further about rules for partial differentiation. We have done. Please subscribe our YouTube channel.